So in this calculation here, first of all, we're just doing a very simple gas calculation. There's nothing complicated about this. So the first thing to do when you're doing a gas calculation is to use the equation PV equals nRT, but it's always wise to write down at the side what information you've got. Rearrange the equation before you put your figures in. And so don't forget your volume has to be, so your pressure has to be in pascals, so we've times it by 10 to the 3. The temperature has to be in Kelvin. Don't forget that the temperature must be in Kelvin, so we'd have added 273 to it. And then we rearranged it to get volume on its own. And it's a nice simple calculation, 3 significant figures, volume equals 0.113 metres cubed. Right, the next part of the calculation is simply a reacting masses one, and we're being given the volume of a solution and the concentration, so we're going to be using the equation N equals C times V. If we're using N equals C times V, notice that the volume, as I've said, I've converted it here into dm cubed because solutions work in dm cubed. So the amount, or the number of moles of phosphoric acid that we have, is 15 times 10 to the 3. And because it's a 1 to 4 ratio, the number of moles, or the amount of P4O10, has to be divided by 4. So make sure you go back to the stoichiometric equation. So that gives us 3,750 moles of the phosphorus oxide. Finally, to get the mass, tell the examiner you're timesing the number of moles by the MR. Calculate the MR at the side, because that's often something you can make a mistake with on your calculator. And that results in a huge mass of 1.65 times 10 to the 6 grams. In this calculation, what we're trying to do is find the percentage yield. So if we work backwards, the percentage yield is equal to the actual yield divided by the theoretical. So that can either be number of moles or it can be mass. So in my calculation here, most important thing to get correct first of all is your molecular masses. So the relative molecular mass, or relative formula mass for calcium phosphate, is 310. So make sure that you can add up correctly on your calculator. And therefore, to get the number of moles, tell the examiner that you're dividing your mass by the MR. Now here they've given us the mass in kilograms, so make sure you can convert your kilograms back to grams again. So the mass is 3.50 times 10 to the 3 grams divided by your MR, which gives you 11.28 moles. So notice here I'm not rounding down yet to 3 sig figs, because that can introduce problems later on. Now it's at this point you go and look at the stoichiometric relationship, because 1 mole of your calcium phosphate gives 2 moles of your phosphoric acid, and therefore we're going to expect twice as many moles. So 11.28, how did I get the 11.28? Remember, that was the mass over the MR. So we would expect to get 22.56 moles of our sulfuric acid. So I'm just going to, of our phosphoric acid. So I'm going to put that, the units there, moles. So expecting that many moles of our H3PO4. Now that is the expected or the theoretical number of moles, but actually what have we got? Well, they've told us that we've actually formed 1.09 times 10 to the 3. Where did the 10 to the 3 come from? Well, it's 1.09 kilograms, so it's 1.09 times 10 to the 3 grams, divided by the MR, because we're using mass over MR. There's the MR of phosphoric acid, and again I've not rounded it down. So this is the actual number of moles, the actual amount of our phosphoric acid that we've made. So it's really important at this point to have the equation for percentage yield. Tell the examiner that's the one that you used. So it's the actual amount, so make sure there that is in moles, divided by the theoretical or calculated moles. So the percentage yield, again we've not rounded it down until we get to our final answer, comes to 49.3%.